Good morning, North Crowley. Let's go ahead and get started working on these gas law equations. So we're going to begin right here at Boyle's law. And Boyle's law is always the first one that we do because it is the simplest one. It requires the fewest numbers of steps to actually work through these problems. So let's go ahead and take a look at number one. So as you can see, our equation's already included for us here at the top. It's P1 times V1 equals P2 times V2, which means initial pressure times initial volume is equal to final pressure times final volume. So when we look at our equations, we have to read them and understand what they're saying to us. So here it says if 22.5 liters of nitrogen at 748. These are both initial readings. This is our initial information. And we know that liters is going to be our volume. So this is going to be our V1. And then it tells us that our pressure is going to be 748 mmHg. So this is going to be our P1. And it says that we're compressing it to 725 mmHg. So this, of course, is going to be our P2. And it's a constant temperature. This is just useless information. We don't need that. It asks us what's our new volume. So we're solving for V2. So I'm going to start solving these all the exact same way. So just so you can see how, they're solved all the same. So over here on the side, I'm going to put in all of our variables. So we got V1 is equal to 22.5 liters. P1 is equal to 748 mmHg. Our P2 is equal to 725 mmHg. And then our V2 is what we're actually solving for. So this is what we're solving for. Next, we're just going to plug them into our equation. So we have 22.5. And we're going to put it in parentheses. That's just going to tell us that we're going to multiply it. I don't like writing numbers side by side without parentheses. So we're going to put them in parentheses. And then over here, we're going to put 748, close parentheses, bring in the equal sign. And then our P2 is going to be 725. I'm gonna keep the order the same way. So 725 goes here in parentheses. And then be sure to include what you're solving for. So we're solving for V2. We're going to put in our V2 right here. That's it. Now we're ready to solve. So the way you solve these types of problems is all we're trying to do is isolate our variable. We need to get the variable by itself on the equal sign. And then everything else just needs to move over to the other side. So to isolate the variable, because we're multiplying V2 by 725, to get rid of 725, we're just going to divide both sides by 725. So we divide this side by 725. This cancels out. And now V2 is going to be equal to 22.5 times 748 divided by 725. Let's go ahead and grab our calculator. So that's going to be 22.5 times 748. And that gives us 16,830. And we're just going to divide this by 725. And that's going to give us 23.21. We're just going to round that to 23.2. So V2 is equal to 23.2. And our unit is going to be in liters. We put in liters, we get out liters. So V2 is equal to 23.2 liters. And that's it. We're done. Let's go ahead and move on to the next one. Number 2 says a gas with a volume of 4 liters at a pressure of 205 kPa. So they just gave us our initial information, 4 liters. We know that's going to be our V1. And then a pressure of 205 kPa, that's going to be our P1. And it says that we're allowing our volume to expand to 12 liters. So this is going to be our V2. It says what is the pressure, so we're solving for P2 in this equation. So what we're going to do here on the side, we're just going to write out everything that we know. So V1 is equal to 4. You can put 4.0, but 4 is perfectly fine. P1 is going to be equal to 205. Our V2 is equal to 12. And then our P2 is our unknown. So let's go ahead and plug this in. So it's going to be 4 in parentheses times 205, close parentheses, bring the equal sign, 12, and then we need to put in our variable, which is P2, and that's it. We're ready to solve. So how do we get P2 by itself? It's going to be the same as the previous equation. You're going to see that all of Boyle's law is solved the exact same way. We need to isolate our variable. To do that, we're going to divide both sides by 12. This is going to cancel. Now P2 is going to be equal to 4 times 205 divided by 12. So let's plug that in. 4 times 205 divided by 12. And that gives us 68.3. So P2 is equal to 68.3. And what's our unit going to be? The pressure that we get out is going to be the same as the pressure that we get in, or we put in. So that's going to be kPa. And that's it. P2 is 68.3 kPa. So that's how you're going to solve every single problem that is a Boyle's Law problem. You plug in everything that you have, you isolate your variable, and you're done. It's basically a one-step problem. So let's jump to this next page. I want to solve something over here just so we've solved everything in every spot. So number 5 says a gas occupies 25.3 milliliters at a pressure of 152 kPa. Find the volume if the pressure is reduced to 0.804 atm. This is actually not a good problem because, and I'm sorry, I made this worksheet in a hurry. So number 5, you can go ahead and cross this out. And the reason for that is I don't want you to have to worry about pressure conversions. So we're just going to leave that one out. Let's solve another one that doesn't require a pressure conversion. All right, so let's do number 4. Number 4 says that we have 500 milliliters of gas collected at 745 mmHg. So 500 milliliters, that's going to be our V1, and it's collected at 745 mmHg, that's going to be our P1. What will the new pressure be if the volume is 1.25 liters? So this is going to be our V2. So the first thing we need to do for this problem is plug everything in. So I'm going to write them out down here. So V1 is equal to 500 milliliters. But to convert this to liters, all we got to do is move our decimal point over 3 spaces. So 1, 2, 3. That gives us 0.5 liters. 0.5 liters. Another way to do this is 500 divided by 1,000, which also equals 0.5. But I teach y'all the moving the decimal method because that's going to work every single time forever and ever and ever. So V1 is equal to 0.5 liters. P1 is going to be equal to 745 mmHg. And then V2 is equal to 1.25. And then P2 is what we're solving for. So let's go ahead and plug this in. We have 0.5 in parentheses, 745 in parentheses equals 1.25 in parentheses times P2. Now all we got to do is isolate our variable. To do that, we're going to divide both sides by 1.25. That's going to cancel. Divide by 1.25. Now we plug it into our calculator. So 0.5 times 745 divided by 1.25. And that gives us 298. So P2 is equal to 298. And what's our unit going to be? It's going to be the same as this one. So mmHg. Put it in a box and you're done. That's basically it. That's all the Boyle's Law that we're going to solve. Now we're going to go ahead and move on to Charles' Law, which isn't, it's just an extra step. So here's our Charles' Law equations. And I'm going to tell y'all right now, anything that requires a pressure conversion, I don't like. So the pressure conversion is written for you right here. 1 atm is equal to 760 mmHg, which is equal to 101.3 kPa, which is equal to 760 torr. The conversions are there for you, but if it asks you to convert pressure, I'm gonna tell you right now, you don't have to do it. Just because I made this last minute just to make sure that you guys had substitute assignments for the assignments that you missed. If it requires a pressure conversion, you don't have to do it. Just skip that problem. But most of them shouldn't have that because I've been using these problems for years. So let's go ahead and look at number 1. Number 1 says calculate the decrease in temperature when 6 liters at 20 degrees C is compressed to 4 liters. So here's our initial information. 6 liters, that's going to be our V1. 20 C, that's going to be our T1. And we're compressing it to 4 liters, that's going to be our V2. So let's go ahead and put it all on the side. So V1 is equal to 6. T1 is equal to 20 degrees C plus 273, which gives us 293 Kelvin. And then V2 is equal to 4. So let's go ahead and plug that into our equation. Here's our equation up here. V1 over T1 is equal to V2 over T2. So we got 6 over 293 is going to equal 4 over T2, which is what we're solving for. So let's go ahead and solve this. How do we solve something with division on both sides? We're going to cross multiply. So 293 times 4. Let's grab our calculator. 293 times 4. That gives us 1172. So we're going to write 1172. Now the next thing, which a lot of people forget, is you need to put in the equal sign. Now that we've multiplied this and this, we put it on one side of the equal sign. And now we're going to multiply this, and we're going to put it on the other side of the equal sign. So 6 times T2 gives us 6 T2. And that's it. Now this looks just like a Boyle's Law problem. So all we did is add one extra step. So you cross multiply, and then it looks just like a Boyle's Law problem. And all we need to do is isolate our variable. So to get T2 by itself, what do we got to do? We're going to divide both sides by 6. So let's go back to our calculator. This number divided by 6 gives us 195.3. Here our 6's are going to cancel out. So T2 is equal to 195.3. And then what unit should this be? This should be Kelvin because we put in Kelvin. So that's Kelvin right there. All right, let's do another one, this time one with millimeter conversions. So over here, it says a gas occupies 900 milliliters at a temperature of 27 degrees C. So here we got two conversions. This is going to be our V1. This is going to be our T1. What is the volume at 132 C? So this is our T2. So let's go ahead and line up everything we got. So V1 is equal to 900 milliliters. We're going to move our decimal point over 3 spaces. That gives us 0.9 liters. Our T1 is going to equal 27 plus 293. I'm going to plug that into a calculator just so 273 plus 27. That gives us 300. And then we got 132. So this is our T2. 132 plus 273. And that gives us 405. So T2 is equal to 405. And here we're solving for V2. So let's plug it into our equation. So that's going to be 0.9 over 300 is equal to V2 over 405. And that's it. Our next step is going to be cross multiplication. So 0.9 times 405. And that gives us 364.5. And then that's going to equal 300 times V2, which is 300 V2. And then our last step is going to be to isolate our variable. So we're going to divide both sides by 300. That's going to cancel. So V2 is going to equal 364.5 divided by 300, which equals 1.25. So V2 is equal to 1.25. And our unit for this is going to be the same thing that we put in. We put in liters, we get out liters. So, and that's it. Let's go ahead and move to the second page. I hope there are no conversions here that you can't do. Actually, there shouldn't be because we're not working with pressure. We're only working with volume and temperature here. I'll do one more and then I'll let you guys work this out on your own. So 3.5 liters of gas at 727 K. So this is going to be our V1. That's going to be our T1. And it's going to occupy how many liters at 153 K. So this is going to be our T2. So let's just plug it into our equation. I'm going to do it without writing everything on the side since they're already labeled. We got 3.5 divided by 727 is equal to V2 over 153. We're going to cross multiply 3.5 times 153. That's 535.5. And then we got 727 times V2. So this equals 727 V2. Then we isolate the variable, so we're going to divide both sides by 727. This is going to cancel. And then our final answer will be 0.736. We're just going to round that to 0.74. So V2 is equal to 0.74, and the unit is going to be liters. Make sure to include your unit in your answers. And that's it. Let's go ahead and move on to Gay-Lussac. All right, so you're going to see pretty quickly that Gay-Lussac is very much like Charles' law. It's exactly the same as Charles' law. The only difference here is you're going to be given pressure and temperature. So no volume in this equation. Let's go ahead and plug this stuff up. So determine the pressure change when a constant volume of gas at 1 atm is heated from 20 to 30. So this is going to be our P1. This is going to be our T1. And this is going to be our T2. So over on the side, we're going to do P1 is equal to 1 atm. And then T1 is equal to 20 plus 273, which is equal to 293. And then T2 is equal to 30 plus 273, which is equal to 303. And then P2 is what we're solving for. So let's plug it into our equation. It's going to be 1 over 293 is equal to P2 over 303. So first step is going to be cross multiplication. 1 times 303, that gives us 303. Bring in the equal sign. And then 293 times P2, that gives us 293 P2. Our last step to isolate the variable, we're going to divide both sides by 293. That's going to cancel. And then our final answer is going to be 303 divided by 293, which gives us 1.03. So P2 is equal to 1.03, and the unit's going to be the same thing that we put in, so this is going to be ATM. Box it up and you're done. I don't think I need to do very many of these, but I will warn you, some of these might require conversions. If they do, you can skip them, but I don't think they will. They look okay to me right now. So I'm going to solve this one right quick just because it's got standard temperature and pressure. So it says a gas has a pressure of 699 mmHg at 40 degrees C. So this is going to be our P1. This is going to be our T1. It says, what is the temperature at standard pressure? So standard pressure we know is 1 atm. So 1 atm is going to be our P2. So let's go ahead and solve this. So P1 is equal to 699. T1 is equal to 40 plus 273, which is going to equal 313, I believe. And then P2 is equal to 1 atm. You know what? That does require a pressure conversion. But we know that 1 atm is equal to, well, it's not written in this one. 1 atm is equal to 760. It's written on this one right here. 1 atm is equal to 760 mmHg. I am going to solve it, but I would think that this one is not, like, you don't have to solve this one just because of that conversion. Don't want you doing these conversions because you don't really need them for what we're going to be working on next. So this is going to be 760 mmHg, and then we can go ahead and solve for T2. So it's going to be 699 over 313 is equal to 760 over T2. And then we're going to cross multiply. So 313 times 760. That's 273,880. And that's going to equal 699 over 699 T2. And then we just need to isolate our variable. So we're going to divide both sides by 699. That's going to cancel. So T2 is going to be this number divided by 699, which equals 340.3. So T2 is equal to 340.3. We're just going to do 340. And then our unit for this is going to be Kelvin. Box it up and you're done. And that's it. Just work these problems out, turn them in, and you're good to go. All right, we're almost finished. We just did 3. We have just a couple left. So next we got combined gas law. Combined gas law is everybody's least favorite. I don't really like them, but you need to learn them, so we need to go over them. So the difference with combined gas law is now we have 5 variables and we're solving for a 6th. So first thing I'm going to do is I'll write out our equation up here. So P1 times V1 over T1 is equal to P2 times V2 over T2. Let's go ahead and work this first one out. If I initially have a gas at a pressure of 12 atm, a volume of 23, and a temperature of 200. This one's pretty simple. It told us all of our initials. So this is going to be P1, V1, T1. And then it says you raise the pressure to 14 atm, so that's P2. And you increase the temperature to 300, so that's T2. What is the new volume? So we're solving for V2. So over here on the side, we're just going to write everything out. So P1 is equal to 12. V1 is equal to 23, T1 is equal to 200, and then P2 is equal to 14, V2 is our unknown, and then T2 is equal to 300. So let's go ahead and plug it into our equation. This is going to be 12 times 23 over 200 is equal to 14 times V2 over 360, or no, that's 300. That looks like 360. So 300. And that's it. We're set up, ready to solve. So this one is no different than a Charles Law problem. It just adds one extra step to it. So what is that extra step? We need to first make sure that we have one number in each corner. Over here we have one number, here we have one number, here we have one number, here we have 2. So we're just going to combine like terms. So 12 times 23. That gives us 276. So 276. And now it's just a regular Boyle's, or no, it's just a regular Charles Law problem. So let's go ahead and cross multiply. 276 times 300. That gives us 82,800. Bring down the equal sign. And then we need to cross multiply the other side. So 200 times 14. That gives us 2,800 V2. Our last step is going to be to isolate the variable, so we're going to divide both sides by 2,800. That's going to cancel, that's going to cancel. V2 is going to be 82,800 divided by 2,800, which equals 29.57, which is 29.6. So V2 is equal to 29.6. And our unit is going to be liters because that's what volume always is. That's it. We're done. I'm going to do one more like this just because you can see they are a little bit more complicated, but they are not difficult. So let's go ahead and do number 5. It says a sample of gas occupies 50 liters at 280 Kelvin, 640 mmHg. What is the volume at standard temperature and pressure? So this one gives us standard temperature and pressure. So let's go ahead and line it up. So we got V1, T1, P1, and then it's asking us for volume. So we're solving for volume. Our standard temperature is going to be 0 degrees C, and our pressure is going to be 760 mmHg. So let's go ahead and put it all over here. So V1 is equal to 50. P1 is equal to 640. T1 is equal to 280. V2 is our unknown. P2 is 760. And then T2 is equal to 0 plus 273, which is 273. Now we can plug it into our equation. So 50 and we're going to multiply that by our P1, which is 640, divide by 280, bring in the equal sign, V2 times 760 over 273. So first thing we're going to do, we're going to make sure we have one number in each corner. So we're going to start by multiplying these two. So let's grab our calculator. That gives us 32,000. And then now we're good to cross multiply. So 273 times 72,000. That's 8,736,000. Bring down the equal sign. And then 280 times 760. And then that's 212,800. And then don't forget the V2. That's the most important part. If you forget the V2, you're going to divide backwards. It happens all the time. So bring down the V2. Now our last step is always isolating the variable. To do that, we're going to divide both sides by 212,800. That's going to cancel. Now we can go to our calculator, pick our old number. Divide that by, and then that gives us 41. So V2 equals 41, and the unit's going to be the same unit we put in, which is liters, always liters for volume. And that's it, we're done. So this is combined gas law. We're almost finished. Now we have ideal gas law. And ideal gas law, in my opinion, is one of the easier ones because you only get one of each variable. The only thing here that you got to remember is you need to pick the right R. So let's go ahead and solve a couple of these. All right, so it says we have 4 moles of a gas. So our N is equal to 4. It's at a pressure of 5.6, so P is equal to 5.6. And volume is equal to 12. So because our pressure is an ATM, we're going to use the unit that comes with ATM, which is going to be R equals 0.0821. Make sure to include that 0. That will mess up your answer. Now we just plug stuff in. So we got PV, so 5.6 in parentheses, times 12 in parentheses, equals 4 times R, 0.0821, and we're solving for T. So let's go ahead and plug that into our calculator. So we got 5.6 times 12. That gives us 67.2. Bring down the equal sign. And then we have 4 times 0.0821. And that gives us 0.3824. And be sure to bring down the T. So now our final step is going to be to isolate the variable. We want T by itself, so we're going to divide both sides by 0.3821. That's going to cancel. So 67.2 divided by 0.3821, and that gives us 175.87. We're going to round that to 175.9. So T is equal to 175.9, which could also round to 176. And that's it. That's our temperature in Kelvin. And we're done. So an important thing to remember here, is that you can put in your pressure in any unit. And same goes for all the gas laws. Whatever unit you're given, that's the unit that you're going to put in for pressure. But the other ones, make sure that you put in what's requested. So volume needs to go in liters, temperature needs to go in Kelvin, moles need to go in moles. Let's do one more of these and then we'll move on. So let's do one that requires a little bit more conversions. All right, these aren't quite as let's go ahead and solve number 5. So number 5 gives us our N. So this is our N value. This is our temperature value. This is our volume. And we're solving for pressure. So here we're not given a pressure unit. When you're not given a pressure unit, always use ATM. So let's go ahead and solve this one. So N is equal to 17. T is equal to 67 plus 273, which is going to equal 340. And then V is equal to 88.89. I'm just going to put 88.9. And it's okay to do these rounds. I don't mind it. And our pressure is going to go in as, our R value is going to go in as 0.0821, which is for ATM, which is why our unit, when we pull it out, it's going to be in ATM. So let's go ahead and plug this all in. We got P is what we're solving for. Our V is 88.9. And that's going to equal 17 times 0.0821. Put that in parentheses too. And then our temperature is going to be 340. And that's it. So with this one, let's go ahead and multiply those numbers. We got 17 times 0.0821 times 340. That gives us 474.5. So 474.5. And then our last step is going to be to isolate that variable. I'm going to bring everything down so you can see it. So P times 88.9. We need to isolate the variable. So to get it by itself, we're just going to divide both sides by 88.9. That's going to cancel. We can divide this by 88.9. And that gives us 5.33. We're going to put 5.34. So P is equal to 5.34, and our unit is going to be ATM. The reason it's ATM is because we put in the R value for ATM. And that's about it. That's 33 minutes, a bit longer than I thought I would spend doing this. But I do have one more that I'd like to do with you guys. So the last one we're going to solve together is going to be the mixed gas law equations. And mixed gas laws, this is where things get a little bit more difficult, just because you have to figure out which gas law you're going to use. For everything up to this point, you were given the gas law, you were given the equation, you just had to plug stuff in. For these, you have to read it. You have to find out which gas law you need, and then you use that gas law for that equation. So first thing I want to do is I want to run through these and see if we could figure out which gas law is required for that equation. So let's go ahead and go through these. So this first one right here, it says a constant volume of oxygen is heated from 100 to 185. So that's our T1, that's our T2. The initial pressure is 4.1. So P1, what is the final pressure? So we're solving for P2. So which equation do we use for this? So the only equation that has pressure and temperature is going to be Guy-Lussac, which is P1 over T1 equals P2 over T2. And the gas laws, they should be available to you. We've already gone through all of them. I would write them down just to make sure that you can solve stuff like this. This is what you're going to see on the test. So be sure you're ready for these types of equations. Let's go ahead and do the next one. It says a sample of 25 liters of NH3 gas at 10 degrees C is heated until it fills a container of 50 liters. What is the new temperature? So this is just going to be V1, that's going to be T1, that's going to be V2, and we're solving for T2. So which equation is this? This is going to be Charles. V1 over T1 equals V2 over T2. This next one says an unknown gas weighs 34 grams and occupies 6.7 liters at 2 atm and 245 K. What is its molecular weight? This is actually a higher level problem. I'm not going to have you solve this. Let's go ahead and cross out number 4. And you can do this. There's no reason why you shouldn't be able to solve this. It's just we're not tested on it, so I don't want to waste any time on it right now. So let's close that, close this. Let's go down a little bit more. Let's do 5 and 6. All right, so an ideal gas occupies 400 milliliters, that's V1. At 270, that's going to be P1. At 65 C, that's T1. If the pressure is changed to 1.4, that's P2, and the temperature is increased to 100 C, that's T2, what is the new volume? So you're solving for V2. Which equation has 6 variables? That's going to be combined gas law. So P1 times V1 over T1 equals P2 times V2 over T2. Next one is, what is the volume of a 23 gram neon gas at 1 C and a pressure of 2 atm? So this is another one of those problems that you do not have to solve. So we'll go ahead and cross out number 6. All right, number 7. The pressure is 6.5 atm, 2.3 moles of Br2, occupies 9.3 liters. What is the temperature in C? So this one gives us moles. If it gives you moles, it's most likely it's either the moles are there for no reason, or this is an ideal gas law equation. So we got 6.5, that's going to be our P1. And this is our V1, and we're solving for T, well, these are, the ones don't really matter. So that's our volume, pressure, temperature, and we can get the R value just because we have the ATM. So this one, and I'll just go ahead and solve it. But we have, this is a PV equals nRT. So 6.5, our volume is 9.3. equals N, which is 2.3, and then R is going to be 0.0821, and we're solving for T. Very simple problem. You just got to read it, see what it gives you, know which equation you're going to use. Next one is, all right, so I think that's about it. I'm going to leave the rest up to you guys. You should be able to solve the rest of these on your own. If you already have a grade for these assignments, if you have a grade for the mixed gas law, if you have a grade for the Boyles and the Charles, you don't need to worry about turning these in. I put them in here as makeup work for those of you who have zeros in the grade book. So if there's a 0 or if there's a blank grade there, you definitely want to make sure to get these done and get them turned in ASAP. I honestly think that you can finish this in a single afternoon, and that could be the difference between the A that you want or the other grade that you